This is another video that links up to the September 11th in-class session. My hope is that you are able to watch and play with these videos along with the data ahead of class, and then we can sort of answer the questions. It will connect to the video previously around projections. You may recall from that video we really defined this concept of a projection, the rules that govern the shape, the size, and the direction that geographic objects take when you load them into ArcGIS. And there was an additional video after that discussed some of the primary ones that we use: state plane, universal transverse Mercator, etc. This third video in the series is going to be more of a troubleshooting one, which is around how do I fix broken data? What happens when I get data that will not show up, that is totally wrong and in the wrong place, and I need to put it in the right place? And then how do I do the more innocuous element where, the Seattle example. Okay, Seattle is showing up and doing its best to align itself in Philly's coordinate system, but it has its own internal system and its own internal rules that are different, that maybe have different units of measurement, and I would want to have those corrected. And the terms we're going to focus on here are called define, project, and project. These are the two tools that will allow you to take broken data and fix it. I'm going to, in the resources or file section or via email, I'm going to share this with you too. I think it's another good resource for you to have. Just a great blog that was put together about this exact concept. You'll have my videos as one, but this is, I think, just a good thing to bookmark because, I'll try and, unless I'm trying to purposely force you guys to project or fix data, I'll almost always give you good data with solid coordinate systems. But the world is an effed up place, and data is a perfect reflection of that. Data is messy, it's all over the place, and there is a good chance that when you get out and start to find data for yourself, you will encounter broken data sources innumerably. So it's just sort of a good resource to have at the tip of your fingers. It offers nice analogies between the difference of these two things, so on and so forth. So let's play first with my projection's totally messed up and it's not even showing. And we're going to do that with Philadelphia bad, right? So if I'm going to take Philadelphia bad and drag Philadelphia bad in, nothing happens. I don't even see it anywhere. If I try to zoom to the layer, it goes nowhere. It doesn't even know how to show itself. That's how busted it is. When that happens, your first step is going to need to go to the properties. Right-click and go to properties and try to figure out what the heck's going on. Right, so we can see a couple problems right here. Let's open the extent and then the spatial reference. Right, the extent is trying to tell it, hey, when you draw yourself, make these four coordinate points your north, south, east, and west boundary and draw yourself there. And the spatial reference is telling you the coordinate system. Well, there's the problem. We have a Philadelphia thing that is projected in a New Zealand geodetic datum coordinate system. We have really no idea sort of where it is or the rules that are governing it. It's linking itself to a central triangulated point to try to figure out where it is, and it winds up being nowhere. And it's further represented by this. This is a frequent thing that happens when data gets messed up. This reads as the unit of measurement and then the unit itself. DD stands for decimal degree, and we will return to this, fairly regularly. In particular, we'll do it on the video where we plot coordinates, x and y coordinates. But the world would split itself into a graph that looks like an x and a y axis, and if you imagine the x-axis is east-west and the y is north-south, you could pin the world in a way that the westernmost axis would be negative 180, the easternmost would be 180, the southernmost would be negative 90, and the northernmost would be 90. So that's what DD is looking for. It wants numbers that get no higher than 180 and no lower than negative 180, but it's getting these ones that are in the millions. And the reason is, and it's not wrong, it's just sort of a screwed up thing here where this map is actually projecting itself in feet, right? It's an interesting concept. You know, we had just learned when we dragged in a piece of data that the linear unit was feet, meaning that when you measured it or when you tried to calculate its sort of weight or area or put it into tools that we'll learn in a couple of weeks, that feet would be the output point that comes through. And you can also have your coordinates read in feet. You know, we'll learn this when we plot points in a couple of videos. But that's the disconnect. That it's trying to say, hey, I'm a foot, I'm feet. And this person's saying, no, I read you as decimal degrees. So it absolutely has no idea how to find itself in the world. And so the fix for this is you do something called define projection. Now we're going to jump into the tools real quick. This makes up a huge portion of the middle and end part of the semester, analytic tools. But we'll dip our toe in it today. You know, the nice thing with tools is in a little bit I'll show you how you can browse the toolbox and see every single tool that we're going to use. But in the beginning, you can always like find a tool, and we'll type in this one here, which will be define, and define projection should come up. There it is, so we can double click it. Oh, it's not what I wanted. Define. Click on define projection, and there it'll come up. And, you know, this one, really all you need to know is what's the bad piece of data, Philly bad, and then what you need to know is what is the actual coordinate system, like what am I changing it to? And I can say just change it to correct. We just want it to be Philadelphia correct. Please put yourself there and fix yourself. And run the tool. It doesn't create a new piece of data, it just rewrites the projection. And there we go. Now we have that green piece of data, Philly bad, where it's supposed to be in the world. Right, so when you're running define projection, it's meant to be done for the completely broken and busted pieces of data that you find. But more importantly, you can't use it unless you know where it's supposed to be, right? So this is an important point that when you're working in data, right, or when you're working with geographic data, we're almost always going to be at that local level for a lot of parts of this class, right? So you'll be in Universal Transverse Mercator or State Plane, or if you're working internationally, a similar sort of coordinate system that meets the needs of that country, although Universal Transverse Mercator would sort of satisfy that need globally. You just need to know which of those zones that you're in, right? So we know when we're in Philly that we need to be in the Southeast Pennsylvania coordinate system, and so, you know, that's why we picked it by saying, we'll just take on the same coordinate system that Philly correct is, because we know it's sort of correct. So the other one is define projection. So I'm going to bring in Philadelphia wrong projection. And this one's different, right? It comes in and you might think like, oh, all's good. What's the problem, Shay? It's drawing itself. But the problem here is the Seattle problem, right? We come down here and see that it's actually in the Universal Transverse Mercator. And there's nothing necessarily wrong with that. It'll do its best. But the problem is that the unit here is meters. So I've got one piece of data, Philly correct, that whenever I take it into whenever I take it into a map and measure it, the output will be feet. And then I've got another one that whenever I take it in, the output would be meters. And we sort of want to align them so that they're not with the wrong coordinate system, because it'll help with future mapping and editing. And the way you do that is you do what's called project. And you can get there in sort of two ways. You know, you can come to the same toolbar we were in here and scroll down and find project. That's one way to do it. And ultimately here, you would just sort of drag in the wrong projection. Anytime you see an output data set, it means it wants you to save a piece of data. So I could come to desktop. Maybe I'll create like a new folder, call it like temp save. Maybe call this better data or something like that. And I'll say the same thing. Look, I want my coordinate system to be Philadelphia correct. And geographic transformation we don't need here. This is sort of a little more advanced, and you'll have to watch the videos on the channel to really go here, but this is in those rare cases where it's not just the projection that's wrong, but also the datum, the geographic coordinate system that orients you where you are in the world. You sort of need to make transformation, me to you to me, so on and so forth. So it's worth kind of playing with that, but we don't need to do it today. So I'll hit run on this, right? Nothing comes in because I saved it to a folder. So I got to come up in here and refresh. I'll refresh, and where did the heck did I name that thing? I don't remember what I called that folder. This is old man brain coming in here. Did I call it temp save? Yeah, there's so better data. Drag in better data. Right, there it is. And the difference just is that when I go to its properties, it's in the same foot and projected coordinate system as the other data. So that's project, right? Project is I'm showing up fine, I know where I am in the world, but maybe I just need to have the same rules that govern the way I should look so that when you measure me and when you map me, my output units will be the same as the other data that you are looking